Alright, welcome back. So, today I'm going to show you how I made this little circuit for my project. So, it needs two sources of power currently. I'll give you a little demonstration after the explanation. Let me give you a rundown of the components. Sorry, I have a gas mask on because I did a lot of soldering and I don't want heavy metals in my lungs. So, I used a clone Arduino Nano, okay? And there's this status LED that I didn't code yet because I don't need it. It's not critical right now. So this is the power input screw terminals and this is the solenoid output terminals. Since I don't have a solenoid right now, I just use the normal DC motor. So I can just clip it in and clip it out with those screws. So the two most critical components are right here. Let me show it. This one, that's a diode right there. And this has to be IRFZ44 something. I don't remember the model. Hold on, let me check. Because most of you guys are going to ask me. It is the IRFZ44N. Just the exact MOSFET I used in my schematic. Alright, so this is basically just the giant transistor. Most of you all know what a transistor is. Diode is pretty simple as well. It lets electricity flow this way, but not this way back. The reason why we need that is it's called potential energy and snapback protection. What is snapback protection exactly? Well, snapback... Hold on, let me take off my mask. Well, snapback protection is when I give electricity to this motor, it turns, right? But when I turn this motor, it gives off electricity, alright? And I only give 5 volts to this, okay? But when I turn this, it can spike up to very high voltages, and it can fry my MOSFET, it can burn my Arduino, so it can cause a lot of damage. And it takes a long time to, fix because it's all soldered together. So what we need for that protection is we need a diode. And what a diode does is it lets electricity flow into the motor, but not from the motor into the circuit. So it allows it to turn, but when I accidentally turn it, or the way it corresponds to a solenoid is when the solenoid snaps back with a spring, we only make it go forward with the electromagnet, and then the spring pushes it back. But when that spring pushes the solenoid back, the energy gets converted into 24, even 50 volts. Now 50 volts is enough to explode this MOSFET. So while it's going back from these cables, you can see the amperage spike, but it's not directly connected, so this diode protects it, and the electricity cannot go into the MOSFET or into the Arduino. So the diode is very critical. Right now, it doesn't really matter because we're using a motor, but when my solenoid comes, it's very important. Alright, so let's now move on to the demo. The soldering iron is still plugged in, so we're going to try not to topple that over. This is the code. It's pretty simple. It's the same code that you would use for blinking an LED on and off, just for a solenoid. Alright, so first of all, you plug in your Arduino to be able to run the code, so that's pretty important. Make sure your Arduino is running, and I got one wire off. Sorry, I have to plug that back in. Very sorry, I'm just gonna pause it for a second and just screw that. Alright, I just screwed it back, and now let's try it. So this is the motor, and this is the external power supply I hooked up. That is an old cut micro USB cable. So the moment we plug this in, it's going to start turning. It's going to be on for 1 second and then off for 1 second. Let's see if it works. 3, 2, 1. I mean, it works immaculately. So when I turn this motor, the voltage spikes, but it's doing no damage to the Arduino because we have a diode. Alright. I'm not allowed to disclose the full information on the project because I've signed a contract. It's something a little commercial. This is just the basic prototype. Thanks for watching. There will be more updates, and I'm off. See you next time.